Hey there everyone! In today's class we're going to learn about gas laws. This is the start of our next unit. Gas laws are basically all about gases, but what it really is just a set of formulas. So gas laws are basically a set of formulas or equations that we use to help us to describe the behavior of different gases. Now, every single gas are affected by several factors. One of the factors that all gases are affected by is pressure. We've talked about pressure in the past, and we described it as a pushing force. So in this case, since gases are made of molecules, they also exert pressure. Another factor that affects the behavior of gases is the volume of a gas. Okay. Now, the volume here isn't necessarily the amount of gas that's present, but how much space it actually takes up. Another factor that often affects gases is temperature. This is the temperature of the gas or the temperature of the environment that the gas is in. So temperature often affects both pressure and volume, and because it affects pressure and volume, it will also affect how gases behave at different temperatures. And then lastly, the last factor is actually moles. The moles of gas also play a role in the behavior of gases. So in this case, moles actually refer to the amount. Okay, so moles refer to amount, not necessarily volume. Volume refers to space taken up. Okay, so the space taken up by a gas is the actual volume, not the amount. Now, since we've started with pressure, let's just look at pressure a little bit more closely. Okay. Pressure can be measured in several units, and you have been exposed to one already. Okay. You guys know of the unit kPa. kPa is kilopascals. And we also know that normal atmospheric pressure, okay, so P ATM is 101.3 kPa, or 101.3 kilopascals. Now, there are two other units of measurements that we'll use. The next one is ATM, which is called atmospheres. Now, this is kind of the standard one that most chemistry-minded people would use. So in this case, if we were to look at atmospheric pressure, okay, again, normal atmospheric pressure, but instead of in kPa, and we decide to look at ATM as a unit, it actually equals 1 ATM. Okay, so that's why it's considered to be a standard. Okay, eventually we will use both ATM and kPa. It's just that society itself tends to like using kPa because it's been around for a while. And speaking of time, one of the first units that were used to measure pressure is this one here, and it's called millimeters of mercury. So mm is millimeters, Hg is mercury. So it's literally called millimeters of mercury. Because in the old days, they actually do use mercury to measure pressure. It is a very reliable liquid, but because it's toxic, we really don't use it in any of our pressure measuring devices like barometers. So in terms of normal air pressure, if we had to write out normal air pressure in millimeters of mercury, it would actually equal 760 millimeters of mercury. So the way that I've written this out, okay, all of these are the values that we have for normal atmospheric pressure. Which, in our case now, can also be called standard pressure. So whatever values that we have for measuring gases, we always compare it to what it would be at standard pressure. So a lot of the calculations and formulas that we use, we can use them as long as we have some kind of standard in place. Okay, and for pressure, it's one of these three units. Okay, so think of these guys as conversion factors. So if we were to convert from one unit to another, okay, it's not that hard to do. So let's use a very basic example. Okay, so let's say I have 3 ATMs, and I want to know exactly how much that is in kilopascals. Okay, so here's the idea. Because I know that one ATM is the same thing as 101.3 kPa, I can use that as a conversion factor. Okay, so I can set it up as 3 ATM. I want to cancel out the ATM, so I put one ATM at the bottom. And I want kPa, so I put 101.3 kPa at the top. Okay, and when I do my calculation, it's going to be 3 times the amount. So 3 atmospheres, or 3 ATM, is actually equal to 303.9 kPa. So I have successfully converted from one unit to another. And if I want to convert back into ATM, okay, I can use the same number, might as well. All I have to do again is to flip the conversion factor, and I want ATM at the top. Oops. And kPa at the bottom. So 101.3 kPa. So kPa cancels out now, and 303.9 divided by 101.3 gives me my original 3 back in ATM. Okay, so I can do this with millimeters of mercury as well. Okay, and I can go between many different units. Okay, as long as I have a conversion factor for it, it won't be hard to do. So that's why I showed you guys how to do it, how to convert units in this kind of way, because it does make it a little bit easier for you to set things up and organize everything. So again, just to reiterate, when you're talking about a volume of a gas, okay, we know a couple of things about gases already. Okay. The volume equals space occupied by the gas. Okay, so when we say 1 mole of gas is 22.4 liters, technically one mole only occupies 22.4 liters of space. And that is what we refer to as volume, not the amount. Okay? Because really, for 1 mole of gas, you actually have 6.02 times 10 to the 23 particles of gas. Okay? That's the actual amount that you have. And we know that gases can be compressed so that they can fit in a tighter space. Okay, so there's also that to be addressed. So if we know that volume can be affected by pressure, right? Those are 2 factors that affect gases. Well, there's also another one. Okay, another really important factor that affects gases is actually temperature. Okay, and there is an actual standard temperature. Because every time we walk into an environment with a different temperature, that does affect the pressure of a gas, the volume of the gas, okay, that it takes up, okay, in terms of space. So the standard temperature that we measure things at is actually 0 degrees Celsius. So a standard temperature of gas is 0 degrees Celsius. Okay. It's not room temperature like we think, okay, but it is 0. However, we do most of our work at 20 degrees Celsius or so. So sometimes the stuff that we do, we have to slightly adjust it, and we know that there is a slight experimental error when we do things. But all these standards, okay, standard temperature, a standard volume, a standard pressure, okay, we can organize all of that by saying STP. STP literally stands for standard temperature and pressure. Of a gas. So the standard temperature is 0 degrees Celsius. The standard pressure is 1 atm. Okay, so when a gas is at standard temperature and pressure, so when a gas is at STP, 1 mole of gas equals 22.4 liters of space, which is what we call volume. So technically, in the stoichiometry unit, when we first learned that 1 mole of gas equals 22.4 liters, okay, the temperature and pressure should also be at standard, okay, in order for this to be true. So this one statement here that STP, right, it's telling us that gases are affected by temperature and pressure, and because it's affected by temperature and pressure, 1 mole, a certain amount of gas, would take up a certain volume, okay, of space. So it all kind of joins in together. Okay. Most of the time, these 4 variables or factors can change. Thus, new slash different gas laws are used to calculate or predict how these gases behave. And that's the whole point of our gas laws unit. We will look at about 5 to 6 different gas laws, or 5 to 6 different formulas, and learn how to use those formulas to predict and calculate how pressure, volume, temperature, and moles might change. All right, that's all the time I have for today. Okay, next video that you'll watch will basically introduce the first gas law, which is called Boyle's Law. See you guys next time.